Let us you have to understand why sky is blue. Why not red, black? The light we see from the sky, it is sunlight scattered by a molecules in the atmosphere. The different layer of molecules are there. The ozone layers, okay? Different ozone layers. So, lot of protector are there. Lot of protector are there. And the molecules are much smaller than the wavelength of the light. That molecules are much more small as compared to the wavelength of the visible. What is wavelength? You have to know the wavelength first. This is the x-axis and this is the y-axis. The wavelength. Okay. Then it is starting from this x-axis and ending at this x-axis. That means that wave completes 'There are more molecules to scatter the light. Most of the blue is scattered away and leaving the region. That is the region. Sunset time, sunrise time, red color. That today's topic is the wave of light. And we have to understand what your that orange and the at the interface of section of the light and the what is interpolarimeter and thin film interface. Light through a single slit. Qualitative behavior. Quality of light. It passes with a single small. Double slit, what will happen? It's called Young's slit. Diffraction. Optical resolution and the relief. Why is kind of let us coherence and condition of the coherence. What is coherence? Wave optics. The field of wave optics study the properties of the light depend upon the wave nature. What is the wave nature? If you see the graph here, here this is the y-axis. So here rate of increase of the y is the x4. Then it will start rate of increase of y with respect to x is this, and here rate of increase of y. Now y is starting from here, this point y start to decrease. So we are measuring some property of light, like the wave nature. When the light was formed with particle is a dual wave and particle method. The models has to explain the phenomena discussed in the geometry. Let us look the Maxwell theory of natural energy. Maxwell has been theory when you derive, and the discussing image characteristics were over distance much greater than the wavelength. Geometric optics is extremely accurate. When dealing with the size comparable to a small and than the wavelength, wave optics is required. When dealing with the size comparable to the small than the wavelength, wave optics. So, by the interface, that one property unique wave is interference of sound wave can be produced by speaker. The sound wave obstructed by different layers, barrier. So, if the three speakers like L1, L2 distance, and wavelength constructed interference that one when the waves are in phase, that we are not thinking there is a single light, the bunch of light. every segment of the light. We are not observing here the light or wave, but the so when the wave is played, the maximum occurs at the time of the what is it wave? Suppose we are considering a wave that one wave is this is increasing at what rate? This is also increasing at what in the same direction. It is not reverse direction. It is a right positive first quadrant and the decreasing it is also decreasing. Lambda is the wavelength. Okay. So both the are same phase. That it is a constructive. It is a positive attitude. But this is the constructive. Three consecutives have the equal wavelength. Look at the lambda, and they are in every phase angle. This is the time, this is the time or pi, and y is the amplitude. So all three waves are in same phase, and it is called the constructive equivalent. So the total wave displacement at the listener location is sum of the displacement of the two waves. What are this amplitude plus this amplitude? So if two waves are in phase, the sum of their displacement is clear. Now the displacement. Let us look the medium of one wave and coincide with the medium of the other. How? Look, this wave at the first quadrant, first 90 degree, here is 90 degree, here is what? 180 degree, here to here was 270 degree, and here to here was clear. So if it is increasing, it is decreasing. It is decreasing. It is increasing. What disturbs it? So what we are getting is out of phase. The interference is disturbing when the wave are out of phase. If 180 degree out of phase, the sum of the displacement is the in consideration the amplitude. So general condition of interference for the consideration is that it is assumption that all are in phase or phase, okay, but it's random. The part of segment of the wave are two waves can interfere all the following conditions are. What? Two or more independent waves travel over the last part of this conversation. The real source are the wave are brought together at the common. The wave must have the same frequency and must also have the fixed phase relationship. Thus, the over a given distance of time interval and phase difference between the wave dimensions such as of the point. The wave must have the same frequency and must also have the fixed phase relationship. Thus, over a given distance and time interval of phase difference between the wave remain constant. discuss waveform required. Look, how to measure it? Interferometer. That interferometer is based upon the interference of the reflected wave. The two reflecting mirror are mounted in the right angle. For mounting, the third mirror is partially reflected, called the beam splitter. How it works? This mirror and this mirror. Okay. So wave 1, wave 2, and this is what? Beam splitter. Incoming light. Going from this. And this. Then this can say the beam splitter, and this is the detector. Okay. So third mirror is partially reflected, all the beam splitter. Okay. What happened? The incident light hit the beam splitter and is divided into two parts. Part 1 and part 2. Clear? So, the wave reflected from the mirrors at the top and the right are recombined at the beam splitter. What will after being reflected again from the beam splitter, portion of the wave combined at the beam. And the bottom of the difference between the two waves is that they travel different distance between their respective mirror and the beam splitter. What will it? The path length. What? The difference L equal to 2L minus 2L. 2L minus what? 2L1 and 2L2 minus that is LL incoming light. There is a difference. The beam splitter created two beam here and the beam splitter recombined the two beam. So the path length difference is related to the wavelength of the light. What happened? The N equal to del L by lambda. If N is an integer, then waves are in A and produce a constant interval. If N is a half integer, the wave will produce the It's clear. So del L is the factor which is equal to wavelength. It is the assumption of keeping the two mirrors at 90 degrees. In fact, it is not there. For the calculation of the constitutive interference del L equal to my, but m for destructive remember del L equal to m plus 1 by 2. M is an integer of both. So, if the interference is constructive, the light intensity at the detector is down. Called the bright fringe. And if the interference is destructive, detector 0, the call is dark. So, let us see the example what we are observing around the Earth. The helium neon larger emit light with a wavelength of approximately 633. Suppose this light source is used in a interferometer and one of the mirrors is moved at a distance d such exactly n equal to this bright fins are counted, calculated, n become this, and bright fins are counted. Now what is the thing is here? We know the 2L2 minus 2L1 is called del L. Okay? That is what? N of the lambda, and when the mirror move a distance d, the distance traveled by the light change is 2d. Back and front of the mirror, that del L is 2L2 minus 2L1 is equal to 2L2 minus L1, that is what? 2d. And what happens? That says del L is 2d and equal to n del n prime. And d equal to what? N by 2 half. Thus, what I am getting? d is half of that n. The problem. So, thin film interface. What is thin? Assume a thin soap film rests on the float glass. What happened? The upper surface of the soap film is similar to the beam splitter in the interferometer. Upper surface is acting like a splitter. So, it reflects part of the incoming light and allows the rest to be transmitted into soap layer after refraction at air soap interface. That air soap film, thin soap film, that is the distance of the layer. Then phase change, incident light, phase change, then what will look? Both of that is the transmitted rays, and that the ratio of that is 1 and is 1.35 and 1.5 is last, and the rays become 2D, and here should be 1.5, here outgoing rays with the condition for rays travel through the different during combined when they are coherent because they what happens? No phase change. Lambda into m equal to 0 light divided by n. But we get the wavelength change as light wave travel from vacuum into the and number of extra wavelength is equal to 2 by lambda m. Wave reflected by the thin film undergo a phase change. That what happens, the number of the extra cycles traveled by the rays inside the film completely determine the nature of the interface. And if the number of the extra cycle n is an integer, there is a constructive interface. If the number of the extra cycle is half integer, then it okay. Where is it? Then n, then integer constructive. N by 2 it is constructive. D equal. So 2D equal to this constructive interface and 2D equal to this is the destructive. And what? Phase change. Only if n here less than n prime and less than subtract below the prime. 1, 1.35, 1.5. So, thin prime interface is case 1. Case 2, assume the soap bubble surrounded by air. There is a phase change at the top of the bubble. There is a no phase change at the bottom of the bubble. What happens? Since only one wave undergo a phase change, the interfaces are what? No phase change. The interfaces are what? Constructive interface 2D equal to this condition and destructive interface is this condition. Okay? Color and thickness of soap film. Consider a bubble formed from a thin and soapy film that looks blue when viewed at normal incidence. Estimate the thickness of the film. Assume the index of reflection of the film is 1.25 and blue light has a wavelength of 400. Also assume the film is also thin, that thinner films are not able to give constructivity. What happens? The interface here is a destructive, we consider m equal to 0. Then what will happen? 2D equal to this, then what number n will get? That is lambda blue by n prime 2. That is what? 74 nm. D equal to. Let's put the chemical slit quantitative behavior. Light passes through the slit or opening like this. Small hole. And then after this, it casting on the. As the width of the slit becomes closer, small, the wavelength of the light and the pattern of the slit, additional maxima becomes sufficient. Let us look. That is the slit, incoming light. Brightness region. Part B shows light intensity along the x-axis and brightness region on it. White that W outgoing wave. There is the possible outgoing wave.
If you draw the waveform, the rate of the so plane waveform and outgoing
learn because the particular distance that this is a L2, this is a 1, the focal length is also 1 to get the this and this is the D. Okay. Then this is the hypotenuse, it is 1. This is L equal to V by hypotenuse and to get this. For constructive interface, we sin theta equal to M. What we got? We got del L. The del L is what? M delta, where M is a magnetic property of which the spin with the 0 plus 1 minus 1 plus 2 minus 1. Axis of the wave, we observe the bright fringe for that. The light intensity will be large and the wave will be in phase at this tightest speed. For distracting, that d sin theta equal to m plus 1 by 2 lambda. That means what? M is decreased. We'll observe the dark field. M is decreased by the half. Clear? And we observe the dark field. Okay? That first spherical, the that is 0, second is 1, and third is like that M. And we will not be in phase and they strike this. It's not making line. Double slit intensive pattern. The angle theta that making the position on the intensive line move along this slit. What is that? So angle theta, you see that at the slit 0 M and at this font, wave font, that is M minus 1, that is M plus 1, and third wave font, it is a M equal to minus 2 and plus 2, and the fringe area what? From this to this. Because distance between the adjacent bright fringe is h. How? B is the distance between the slit, as you have calculated earlier, and W is the distance between the slit and the slit. Okay, and H is the distance between the adjacent bright fringe. Let us look. Each bright fringe corresponding to the different value of M. A negative value of M indicates that path to those points the slit from the lower slit is shorter than the path from the upper slit. For M equal to 1, sin theta equal to lambda by 2. When M equal to 1, sin equal to lambda by 2. And since the angle is very small, we can see sin theta equal to and theta equal to lambda by 2. So between M equal to 0 and M equal to 1, H is equal to W tan theta. H is equal to W tan theta. And approximately that for a small angle, sin theta equal to theta, tan theta equal to theta, then what will happen? It is approximation. H is equal to W theta. And what is this theta? Theta is a lambda by t. So, interference with the monochromatic light. Light is single frequency is called the monochromatic, you know very well, black and white. And light source with a variety of wavelengths are generally not useful for double slit interference experiments. The bright and dark fringe may overlap or total pattern may be washed out some of bright and dark. So bright and dark figure will be meeting. No bright and dark figure. Make it into shape. Measuring the wavelength of light. Young's double slit experiment shows that light is in wave and also give a way to measure the wavelength. Suppose the double slit experiment. In the figure, this, what you got? H is given 1.5, W is given 1.5, and D is given 0.4. What is the wavelength of the light? From that formula, we know the solution that lambda equal to h by dw. That is equal to 400. Frequency difference. It may be narrow enough to do this dimension, but not so narrow that cannot be treated as a single slit. Assume the single slit has a width of W and light is diffracted as it passes through the slit and propagates through the slit. This is the point. Single slit. Incoming light. White W. Okay? Then what? The key of the calculation where the occurs is what is this? W by 2. Okay? A1, A2, A3, A1, A2, A2. Both wave one. All points across the slit act as a wave force. and defense web generates the string. So let's divide the string into two parts. What happens? One of point is each part of the string satisfy the condition of the destructive interference and web of the all similar set. Point will be interfered destructively. And what will happen? That del L equal to W by 2 sin theta. And W theta by 2. Destructive interference will produce a dark field. And single slit analysis dark feature. Condition for the destructive interference are W sin theta equal to plus minus m lambda where m equals to 1 and plus minus m. The negative sign will correspond to the pins below and at the center of the. So, single slit analysis right field. There is a no simple formula for the angle at which the right field. The intensity of this string can be calculated by adding up all adjacent. There is a central bright fringe. Central bright fringe called the central maxima. Central fringe is about 20 times more than the intensity of the bright fringe and either side. The width of the central bright fringe is approximately the angular separation of the first dark fringe on the either side of the, that is 2 lambda by W. From the rays is the maximum and this is the minimum. First minimum, that is 1.2. Okay, and that this value, theta value is 1.2 by the theta, that is the intensity y, and this theta value is 1.2 lambda by 2. Clear? So, are sufficient far apart, they can be seen as separate values for if the sources are too close together, so much appears single. Overlap. Understand? Overlapping. It will see the condition ABC comparing. Okay. Source will be resolved as to the distinct source of the line and angular separation greater than the angular range of the signal. So, if the two sources are situated far apart, they can move at a different time. If the sources are close together, they directly want to overlap. With a mistake here, it's not right to see. Okay. It's a overlap. Okay. So, we resolve as to distinct source. If their angular separation is greater than the angular rate of light. This resolves all the negative. For the circular opening, ready criteria for the angular is 1 by 2. Let me see. You have to calculate theta first. Theta will get almost very small, so it becomes the h by l, the theta mean. Okay, and we can calculate the h like this. No problem. So why the sky is blue? We are told